Next type of problems that you're going to encounter will have variables mixed within. And the first thing that I want to say, the instructions are going to say something along the lines of assume that the variable is positive or assume that it's either greater than or equal to 0. Don't worry about that. It just saves you a lot of trouble with having to worry about absolute value symbols. Don't let those words make you think your answer's wrong. It just means solve the problem. You like that, just don't worry about it. So how I am going to approach this problem. I am going to split up the number part and the variable part. And eventually when we get good, maybe we'll just do it in one swoop. But at the very start, I'm going to treat them separately. I'm going to simplify the square root of 20. We'll talk about how to square root or simplify the square root of y squared, and then our final answer, we'll put it back together. So the square root of 20 you can do using the rules that we just learned. So the perfect square that goes into 20 is 4. So 20 is 4 and 5. So the square root of 4 times the square root of 5. Well, the square root of 4 is 2, and the square root of 5 cannot be simplified. And then the square root of y squared. First of all, don't think too hard. But second of all, let's go back to the fact of what a square root is. It means a number times itself is, so 6 times 6 is 36, so the square root of 36 is 6. Y squared is y times y. So if you're talking about the square root of 6 times 6 or the square root of 6 squared, it just ends up being 6. So the square root of y squared or the square root of y times y is just y. It's saying what times itself gives you y squared? Well, the answer to that question is just y. And so because this 2 is no longer underneath the radical, this y is no longer underneath the radical, I'm going to write both of them out front. So I'm going to write 2 times y, and then left underneath the radical is the 5, so 2y root 5. And I would rather see this. I don't want to see 2 root 5y just because I guess I don't know if they'd count it right or not. But it's better to have the variable out front. It's just a good practice to be in. And to definitely make sure that that y is not underneath the radical anymore. So number 6 is going to say the square root of 75 n to the 4th. And so when I think of the square root of 75 n to the 4th, I'm going to split it up into the square root of 75 and the square root of n to the 4th. And I'm going to treat them separately. So I've got the square root of 75. Now the largest perfect square that goes into 75 is 25. It's 25 and 3. So the square root of 25 is 5, and the square root of 3 does not simplify. And then the square root of n to the 4th. So it's saying what times itself gives you n to the 4th. Or I would think about this square root as being something squared. What squared gives you n to the 4th? Well, n to the 4th is 4 n's. N times n times n times n. So if we're talking about groups of 2, how many groups of 2 are there? And the answer is that there's 2 groups of 2, or n squared. So whatever way you think about it, the square root of n to the 4th is n squared. And so for my final answer, I'm going to include it out front, 5n squared root 3. So I usually think about it as the square root is talking about groups of 2. So how many groups of 2 are there if there are 4 total? And the answer to that question is 2 of them. That's how I think about it. Mathematically, you can think about it a lot of different ways. So let's try 4 root 27 m to the 5th. So this 4 being out front just means my final answer is gonna, whatever number's out front, I'm gonna have to multiply by 4. So I'm not gonna ignore it forever, I'm just gonna leave it alone for right now. I'm gonna split up the root to be the square root of 27 and the square root of m to the 5th. So the square root of 27 factors into 9 and 3. So the square root of 9 is 3. The square root of 3 does not simplify. And then we'll deal with the 4 at the end. It wouldn't be wrong to deal with now, but we'll just wait till the end. All right, the square root of m to the 5th. So what times itself gives you m to the 5th? So I would again think about this as groups of 2. How many groups of 2 are there if I have a total of 5 m's? So I have 1, 2, 3, 4, 5. Well, I have one group of m's that I can take out, and I have a second group of m's that I can take out, which means in total I can take out m squared. What's left underneath the square root is a leftover m. So if I took m squared root m times m squared root m, I would get m to the 5th. So how many groups of 2? And then there's a leftover underneath. So when I look at what's in front of the radical, what got pulled out is 3m squared. What's left underneath the radical is a 3 and an m. And then what I don't want to lose is the fact that I am multiplying this by 4. So my final answer is 12m squared root 3m. Both the 3 and